In this video, you will learn how to graph a piecewise function. We will start by graphing the following piecewise function. F of x equals x plus 2 if x is less than 1. F of x equals 0.03 times the quantity x minus 1 cubed plus 5 if x is greater than or equal to 1. Before we begin, we want to make sure that the plots are off. So we'll come up here and we'll select y equals, and notice none of these are highlighted, the plot 1, plot 2, and plot 3. If they were highlighted, you would go up to any one of the specific plots and select enter, and that will unhighlight it. Now you want to make sure that you follow this particular notation when entering any piecewise function, or else your graph will be incorrect or you may get an error. We will begin by entering x plus 2 first with its restricted domain. So you need to put the function in grouping symbols. X plus 2, and then close the grouping symbol. And then we're going to use the division symbol to separate the function and the particular interval. So now we're going to put the interval in grouping symbols as well. So this says when x is less than 1. Now we need to go to the test feature of this calculator. So it's second function and then select the math button. And you can see here number 5 is less than. So we'll select 5 and then 1, and then we're going to close the grouping symbol. Now we'll go and enter the next part of the function. So we'll select enter, and then again you want this next piece of the function in grouping symbols. So 0.03 times the quantity x subtract 1, close the grouping symbol, raise that to the third power, and then add 5. And now we're going to close this function with the right-hand parenthesis. So the entire function is within a grouping symbol. Now we're going to separate this function and the interval by using the divide symbol. And again, the interval needs to be in a grouping symbol. So now we'll enter in the interval, and that says when x is greater than or equal to 1. So we need to go to second function again, and then the math button, which operates the test symbols. So we want greater than or equal to, and that is number 4. And we want x greater than or equal to 1. And then we will close this with a right-hand parenthesis. And now we can graph this particular function. So we'll select the graph key. There's the first piece, and there's the second piece right here. Now, there's a couple things that I would like to point out here. Number 1, notice for the linear function at x equals 1, which is right here, there should be an open circle, which indicates that the value of 1 is not included in the interval for the linear part of this piecewise function. However, for the cubic part of this function, 1 is included in the interval, and this is usually shown as a closed circle at x equals 1. So there should be a closed circle right here, and then right here there's an open circle. Open circle means it does not include that particular point. A closed circle means that it does include that particular point. Now notice that we have two pieces. Here's the linear portion, and here's the cubic portion. Now let's say that we get rid of the restrictions on each particular function. In other words, we're going to graph each function over its entire domain. So let's do that. I'm going to select y equals, and now I'm just going to input the functions without any restrictions. So let's start that at y4. So x plus 2, and we'll move down, and we'll enter in 0.03 times x subtract 1, that's raised to the third power, and then we'll add 5. So let's graph this, and what's going to happen is you will see both functions without any restrictions. So here's the linear function, and here's the cubic function. Now when we restrict the domain for each function, let's go back here, and then we will not graph y4, and we won't graph y5, and remember you just highlight the equal sign and select enter. Now we'll graph it with the restrictions on the piecewise function, and again there's the first piece and there's the second piece. Okay? All right, let's graph another piecewise function. Let's go into y equals, and we will clear all of this. Okay, now we're going to graph f of x equals negative 2x if x is less than negative 2, x squared minus 2 if negative 2 is less than or equal to x, less than 2, x if 2 is less than x, less than or equal to 6, and 8 if x is greater than 6. So we're going to use the same notation, and that is we need to put each function in parentheses, and then we're going to separate that with a division symbol and then put in each particular restriction for each part of the function. And the inequalities need to be in parentheses. Let's do that. So here's the left-hand parenthesis, negative 2x, then close the grouping symbol, separate it with the division symbol. Now we'll enter in the inequality. So a left-hand parenthesis, and x must be less than negative 2. So again, we hit second function and then the math button, and the less than is number 5, and then negative 2. And then we are going to close the grouping symbol, and then we'll move down to y2. So now we're going to enter in the quadratic. So again, a left-hand parenthesis, x squared, subtract 2, close the grouping symbol, separate it with a division symbol. And now this is a compound inequality, and you need to enter this in with a logical operator. And again, we need to put this compound inequality inside a grouping symbol. So a left-hand parenthesis, and we want negative 2 less than or equal to, so second function, math button, less than or equal to is number 6, and then the variable x. Now we want to put in a logical operator, which is the word and. So we're going to go second function and then math, and then we want to move over to logic. And we just want number 1 for and. And then we're going to finish up this compound inequality, which says x less than 2. So x, and then second function math, less than is number 5, and then 2. And don't forget, we need to close this compound inequality, the right-hand parenthesis, and then we'll move down to y3. So this function is just x, and notice that the x is inside the parentheses. We're going to separate it with a division symbol. And again, we have a compound inequality. So we're going to follow the same steps as we just did. So we start out with a left-hand parenthesis, and we want 2 second function math less than number 5, the variable x. Now we want the logical operator and, so second function math, move over to logic, number 1, or we just select enter. And then x less than or equal to 6. So x, second function math, less than or equal to is number 6. And then 6. Again, we have to close this with a right-hand parenthesis, and then we'll move down to our last piece of the function, and that just says 8. So again, the 8 is within the parentheses. And then now we separate that with a division symbol, and we want x greater than 6. So again, the left-hand parenthesis, x, second function math, greater than is number 3, and then 6. And then close the grouping symbol, and now we can select graph. So that's good. We did not get any type of error, which means we inputted this correctly. And here is each piece of the function. Here's the linear function, negative 2x. Here's the quadratic, which was x squared minus 2. And here's the next linear function, which was just x. And then we have a constant function, or a horizontal line, which was 8. F of x equals 8. The one thing I want you to notice here, and it looks like in this area right here that there's no connection, and there actually is. So the first thing I want to do is do a zoom box. So I select zoom and then number 1, and I'm going to create a box around this particular area right here. So select enter, then move the cursor down. So I'm forming the box, and select enter. And I'm just doing this to show you that these two functions are indeed connected. Okay? So let's go back to the standard window. So zoom, and then Z standard number 6. And there's the piecewise function that we just graphed. Now recall, in the previous example, we had open circles and solid circles. Remember, the open circle does not include a particular point on the function, and a solid circle will include the point on the particular function. So take a few seconds here and think where there would be an open circle and where there would be a closed circle. Well, first, right here, if you look at the inequality for this piece of the function, which is negative 2x, it says x less than negative 2. So at negative 2, there should be a hollow dot here because it does not include negative 2. So I called it a hollow dot. You can also say an open circle. All right? Then, for the quadratic part, it says negative 2 is less than or equal to x? Well, here's negative 2, and it does include it because it says less than or equal to. So this will be a solid dot right here. Then the function goes right to this point at x equals 2. Well, we're still on the quadratic, and it says x less than 2. But then, for the next piece of this function, it's a linear function which says f of x equals x. So I want to show you something. If you notice the screen to the right, for f of x equals x squared minus 2, f of 2 equals 2. And for f of x equals x, f of 2 equals 2 as well. So at this point, 2, 2, they're connected. It's the same value. The y value is the same. And the x value is the same. So at x equals 2, y is 2. Then we don't need a closed circle because these two pieces of the function are connected at 2, 2. So for this piece of the function, f of x equals x, it says that 2 is less than x, less than or equal to 6. So here at 6, 1, 2, 3, 4, 5, 6, which is right there, we move up, it includes 6 because it says x less than or equal to 6. So this should be a solid circle right here, or a closed circle. Also, I call it a solid dot. All right? Then finally, the last piece of this function is f of x equals 8, which is right here. So the restriction on this is if x is greater than 6. So again, here's 6, x greater than 6. So all the values to the right are greater than 6, but it doesn't include 6. So this here should be an open circle or an open dot right there. So again, we should have an open circle, a closed circle here. This is continuous. There's no break in these two functions. So at the end of this function right here, we're going to have a solid dot right there. And then for this piece of the function, there's going to be an open circle right here. This concludes the video on graphing piecewise functions.